Hello guys, and welcome back to the tutorial on the Hive Nodal logic system. In previous lesson we were just talking about the introduction to the system, and what's important to know, and the basics. So we were briefly talking about drones, and if you're still confused by them, that's fine. Carry on, and it'll make sense in the end. So what we have is a drone, and we think of a drone as being imprisoned or underwater. We cannot access him. But the drone, if you imagine the drone being an octopus, has little tentacles. And these tentacles can stick up from the water. Thank you, very good artistic skills. In fact, I should probably draw this in blue to help you. And these tentacles are therefore visible from the surface. So we think of ourselves, in fact this is a very bad example because my drone is in fact above the water. So I'll, honestly, you must do it visually correct. So let's have our little drone, and then we have our little tentacles, which aren't so little. Oh, that's not so good. Above the water. There we go. It's only for visual effect, but I dislike bad drawings, as you can tell. So I give up. Anyway, here's the water. And it's going to go up here because this thing's underwater. And so now we can access these. These tentacles are connected to the body of this drone, or this octopus. So these guys here can access this guy here. But we at the surface can only access this. Because these tentacles only talk to us on certain occasions. So we have to then think of these as plugins. And this is a drone. This is why we can't access the drone directly, because it's underwater, and it gives it some unique advantages, like a virtual machine, but for now we won't worry about those. So then how do we access these? Well, we can't actually talk to plugins directly. The way a plugin works is we take the function, let's say add, from our drone, and we create a plugin with the name of the function, which we access it by, add, and then the function itself. Which, if I can write that out better for you guys. And what this does is it essentially just binds a plugin to this method. So now we've created a global plugin, and if we try and create another plugin with this name, it won't work necessarily. That's something for a later lesson, but for an animal machine it doesn't work. So then if we need to access this plugin, we can't access the plugin directly because we don't know how to. We have to call it from something, and we use a special function to get this plugin. And it's the same as plugin, but it is called socket. So if we want to access the plugin called add, we call socket add. And then we call a method that will receive this function as an argument. Let's say adder. An adder is a function that looks something like this. We'll define it, and then if it's on a class, we'll give it the self parameter, and then we'll give it an add func parameter, and then it uses add func 1, 2, and that'll be 3. And hopefully we all see that. So this gives us some big scope for using special hidden methods. So if I go over here and delete that, that one, except the fact I don't want it to be blue, so if we delete that again, and that is how a plugin works, and that's how a drone works. So following on from this, if we look at our previous page here, you'll see we have workers, which we see in the graphical user interface, and these can access these drones using the plugins method. The difference is you can only visualize antennas, outputs, and workers. You cannot visualize in the graphical user interface workers, plugins, or sockets. And hopefully, drones, plugins, and sockets. And you can hopefully see, well, how this is all useful. It means you can make very complex logic without having to put it all into one worker. And it means that other functions can use it. Anyway, back to the tutorial. So if we go back into my existing tutorial, we use drones. The main reason of having drones is that they are a virtual machine, and it means we can use specific drones for specific game engines. Hive is also written to work with, I believe it is Ogre. And the way, if you think about it, Ogre has very different logic inside itself, but it can still run Python. So the way in which we work with this is very simple. We create drones with these functions like add and subtract, which only work in one game engine. So then what we do is we make another drone called maths again, perhaps, or maths_BGE, and it has its own functions for add and subtract, which are specific for the Blender game engine. It then makes it very simple to create a drone for each game engine and simply use the correct drone for the current game engine. This is why if we had to make a new worker each time, it would be very tedious, whereas we can just simply switch in we can switch in the functions that modify the game. Whereas all the other logic, which is likely to be the same in each game engine, like calculating scores and stuff, doesn't have to change. So now how do we progress from here? Well, this is the basics for the system. And what is important to look at? There isn't actually have to go off now. So, as a recap, we have our workers, we have our drones, we have our I/O pins, which are these things here. What else can we do? Well, antennae and outputs have special properties. We can have push antennae, which are right here, or pull antennae. This is not actually correct. I should rewrite this. We can have pull antennae or push antennae, and we can have pull outputs or push. And how do these work? If you have a pull antennae, it means this antennae will pull data from another node, and this means that the other node, which is connected to the worker, must have an output with the same type of pull. Likewise, if we have a push antennae, it receives data which is pushed to it, so the output of the other node connected must also be a push. What it means is that we can choose which worker requests the data, whether we send it forcibly from one worker through the output, or whether we pull it succinctly through the input or the antenna. Hive is statically typed. We have to always explicitly tell Hive what types of data we're sending. So we have to tell it that it's a push antenna, for example. Data is pushed to it. We have to tell it that it's an integer that it's going to receive. That way we can make automatic connections more easy in the system. Furthermore, with all this type matching, we can catch errors if users do the wrong thing. So it's all very useful. And if I quickly just check how long I've got left before I should stop this video. We're here approaching the 10-minute mark. Yes, actually I'll finish the lesson for today. So in today's lesson we basically looked at sockets and plugins and the antennae in more detail. Thank you for watching, and we'll carry on in the next video.